episode of, well, math class, I guess. We're looking at proportionality theorems today, and it's kind of an interesting one today. There's about 4 theorems, and one of them talks about this idea that if you have this line right here, and this segment divides this triangle, it intersects the other 2 sides, and turns out to be parallel to another side. Let's just call this the base, and this is parallel. And what it does is it creates a whole bunch more ratios for our triangles. For instance, down below it says RT and TQ. So now you say that this part of the top triangle piece here is now proportional to the sort of the bottom part of the triangle, and this top part to the bottom part. You could also compare by switching around the means or switching around the extremes. You could compare this side with this side, and it'll be the same ratio from this side to this side. So there's a lot of different ways you can kind of mix these around. You can even add pieces of it together. It's really interesting. And then it says, secondly, the converse, that if these relationships exist, then you can prove that these 2 sides are then parallel. What's really interesting then, and a further extension, is the contrapositive of this. It says that if these 2 are not in the right ratio, then these 2 lines are not parallel. And if these 2 are not parallel, then these 2 are not going to be in relationship to them. So that's called the contrapositive. Let's take a look at how this might apply. So it says use a figure to complete the proportion. And we have all these different lines here. So we have to really kind of look at what's going on. We have GC and CF, and what that's going to do is it's going to help us out with GD to DB. Over here we have AF to FC. We're going to compare that to EB and BD. Over here we have CD and FB. We'll compare that to GD and GB. We're just looking at the sides of this triangle, kind of seeing what's going on. We have AE, which is right here, this base here. We're going to compare that to CD, the base of this sort of this top triangle, I guess. We'll compare that to GE, which is the side of the sort of the big triangle, and we'll compare that obviously to GD. The last 2 here, we're going to have AE. It's kind of the same concept here. And the last one will just be CD. Again, we're comparing GD, this small part. We'll compare that to GE, which is this longer part here. So small triangle, big triangle. And then we have CD, which is the small base, to this big base. These 2 are exactly just kind of switching these guys around. Okay. Use the given information to determine if these 2 guys are parallel. So in order to prove these guys are parallel, what we need to really look at is we need to look at if this ratio is consistent. So what I'll do is I'll just say, I can say 6 over 3, and I'm asking, does that equal 8 over 4? Well, since both these ratios are 2 over 1, since this ratio is the same, I can say yes. Similarly, I could also say, 6 over 9, does that equal 8 over 12? There's a lot of different ways you can write this out. I could have also written, how does 6 over 8, how does that compare to 3 over 4? There's lots of different ways you can write this out, so you kind of got to pick one way and realize what's going on. That is what makes this a little bit more complicated, is the consistency of which you could write these out. So over here I'll say 2 over 1, I'll compare the top part to the bottom part, and I'm going to say, is that equal to 3 over 1.2? If we simplify this and figure this out, these are obviously not the same, so no, those 2 lines would not be parallel. Determine the value that makes these lines parallel. Again, we'll set up some sort of ratios, and there's a lot of different options that we can do. I'll just say 25 over x is going to equal 20 over 8. If we cross multiply here, we'd have 20x equals 8 times, let's see, 8 times 25, then gives me a pretty big number. That'd be 200, and then x would just equal 10. Piece of cake. You could also set this up as 25 over, say, like x plus 25, so that whole side, and you could say that's 20 over 28. You would still get the same answer as you work this out. So again, there's multiple ways of setting these up. So if I set it up one way and you set it up another way, and we still get the same answer, that means we're doing the right thing. Let me set this one up a little bit differently. Let me say this is 12 over 18. I'll use the entire side, and say that's equal to x minus 4 over, this would be x minus 4 plus 8 on that side. So the idea is I'm saying 12, which is just a small part over the entire thing, is going to be equal to this thing over the entire thing. Normally you wouldn't set this up. I just wanted to show you what it would look like if you did. This would be 12 over 18, which you could simplify if you really want. There's like another method we could try this with. This would be x plus 4. Then when we cross multiply, we'd have 12x plus 48 equals 18x minus 72. You could then make this, let's see where I'm at here. This would be 6x equals 120. And then that would be x equals 20. Okay. Again, there's a lot of different ways you can set this up. You can just say it's 12 over 6 equals x minus 4 over 8. You could notice this ratio then was going to be 2 equals x minus 4 over 8. You get 16 equals x minus 4, and then just add 4 to both sides. You could also get 20. So there's yet another way you can solve for this. What's kind of neat is whatever ratio you decide to pick, stick with it, and chances are you're gonna probably get it right as long as you set your problem up correctly. Two more theorems. It just says that if three parallel lines intersect two transversals, then they divide this transversals proportionally. So the idea here is that UW, so this piece right here, in relation to this piece down here, is going to be equal to this piece here and this piece here. The idea, and you can mix these up using exchanging the means, exchanging the extremes, inverting these using the reciprocals. You could add them together. There's a lot of different options that you can do. And the idea here is basically we don't have a triangle, but it acts the same way as a triangle. Lastly here, if a ray bisects an angle of a triangle, so basically if these two are congruent, then what happens is you can again have some proportions. So this guy over this guy equals this guy over here over this guy. What's also neat is you can do this part over this part is going to be equal to this part over this part. It's really kind of an interesting concept of just all the different ways that you can set up proportions once you're given just given a chance, given some of this information. So let's try this out. Again, there's lots of different ways. So if I set something up in one way and you set it up in another way, you're not necessarily wrong. It's just sort of a different way of doing this. We look at this. This is sort of silly. If this is 4 and this is 4 and this is 8, right away we can say that x equals 8. This is really a silly problem. Let's explore some of the ways we could set this up. We could say 8 over 4 equals x over 4. So it's just saying 8 over 4 equals x over 4. We could also set this up saying we could say 8 over x equals 4 over 4 and solve it from there. Or generally speaking, we could honestly just kind of look at this and figure out that it's what it is. Over here, I'll set this up. I'll say 2 over 3 equals x over 3.5. I think that's a pretty straightforward way to do this. That'd be 7 equals 3x. Divide both sides by 3 and x equals 7/3. That'll be our answer. Another way you could set this up is you could say 2 over 5. So 2 over the entire length would equal x over x plus 3.5. That works nicely. You could also say like 2 over x equals, like as a third method you could do this, 2 over x equals 3 over 3.5, something like that. A lot of different ways you could fill this out. Every single way you will get x equals 7/3. Let's take a look at this really quickly. Same concept here, except things are divided up a little bit. So if I was to look at this, maybe I want to compare 11 to just this part of the triangle. So I'll say 11 over, well, we'll come back to that. And that would give me 14 over x. So if I have 14, that's one part of the triangle to the entire thing here. And then maybe I have one part here. I just need to talk about this. The whole thing's 20. If I say 20 minus x, that might be a good avenue to take that in. Then I'll cross multiply. I'll have 11x equals 280 minus 14x. When I get these x's on the same side, I have 25x equals 280. When I divide both sides by 25, I'd get 11.2 as an answer. Over here, we could say 3x over 5x equals, let's see, that'd be 60 over 8x. I could simplify this a little bit, just keep this as 3 over 5. And these are both divisible by 4, so I could say 15 over 2x. That simplifies my problem and my process a lot more. That would give me 6x equals, what is that, 75? And when I divide by 6, I'd get 12.5 as my answer. Even if I kept it this way and still worked this problem out, I should, if I do my algebra correctly, I should still get 12.5 back. Last problem is a little bit more complicated. If we try to use the whole length of 30, that means I have to use the whole length of this triangle. So that'd be 2x plus 6. And that would equal, well, if we talk about comparing this to just x plus 6, something like that, just this part, means I need to talk about just this part of the triangle. Well, the whole thing is 30, and if this top part's 9, it means this part here has to be 21, so I'll take 21 right there. When I cross multiply, that could be 30x plus 180 equals 42x plus 126. I don't know if that fits on there. That would give me 54 equals 12x, or x equals 4.5. Good questions for you to look at here. Sometimes you have some word problems. It says on the map 51st and 52nd Street are parallel. It tells us this, so it might be a nice thing to mark on here. These two guys are parallel. Charlie walks from point A to point B, so he walks 1,200 feet. And then from point B to point C, add those together, that gives us 900, like so. So he walked a total of 2,100 feet. You walked directly from point A to C. How many more feet did Charlie walk than you? Well, Charlie's here to there. We know this is 500, so we kind of had to figure out what this length is first, just from here to up here. What we can do, since these guys are parallels, we can actually set up some sort of ratio. We could say, hey, that's 300 over, well, let's find out the entire length. So we'll use the entire length here. That's 300 over 900 is going to equal 500 over the entire length here. I'll just say this is the entire length. I'll call this whole thing x, like so. Let me simplify just a little bit. This would be 1/3 equals 500 over x. When I cross multiply, that would give me x equal to 1,500. So Charlie walked 2,100, I walked 1,500. If we subtract those two numbers, Charlie walked an additional 600 feet more than me. That's part A. Part B asks you to explain that if Park Avenue, that's this road right here, is perpendicular to 51st Street, like so, is Park Avenue perpendicular to 52nd Street? So does this exist? Well, I think the explanation for this really has to do with, I think the answer is yes. One idea here is that if these were parallel lines, we could then say that, you know, these two angles are going to be congruent, like so, because this is a transversal cutting them. CB is also a transversal cutting them, so we could say these two triangles are congruent. And if one of them is 90 degrees, I'm going to say the other one's 90 degrees as well. So two similar triangles, their corresponding angles are going to be congruent. So there's a lot of different ways you could say this, but it really comes back from the concept of the parallel lines. Now, we could also take a look at an example dealing with photography. I want you to look at that on your own. Just a lot of different ways that you can actually apply a lot of the concepts we're talking about for this class. Remember, it all does come back to proportionality and how you use it.